Hey everybody, welcome back. This is the updated review video for Unit 2, the periodic table. So the goal is to go over the practice exam question by question. So if you wanted to pause this before each question, try it on your own and see how you did, that is a great idea. So number 1, which list of elements from group 2 on the periodic table is arranged in order of increasing atomic radius? So if we are talking about group 2, groups are the vertical columns. As you go down a group, the radius gets bigger and bigger and bigger. So you want elements going down in the same group. So answer choice B. These are some group 2 elements. You have BE, MG, and CA in that order. Number 2, krypton atoms in the ground state tend not to bond with other elements because krypton is Kr. Kr is in group 18. And group 18 are the noble gases. The fancy thing about noble gases is that their outermost electrons are completely full. So for all elements except for hydrogen, that is 8. And because they have their full valence shell, they tend not to bond with anybody. And so the fancy word that says tend not to bond is inert. So sometimes you'll see that word. Number 3, which list of elements of symbols represent nonmetals only? You have your periodic table. Label everything. So Li, B, E are metals. B is your metalloid. B is a metalloid. Aluminum, Al, is a metal. Ga is also a metal. P is nonmetal. S is a nonmetal. Chlorine is a nonmetal. Carbon, nonmetal. Si, metalloid. Ge is also a metalloid. So if we're asked for nonmetals only, it is B. So just remember you have your staircase, which looks like this. Like that. Anything on that staircase is a metalloid. Everything to the left of it is a metal. Everything to the right of it is a nonmetal. Number 4, which grouping of circles, when considered in order from top to bottom, represent the relative size of atoms of lithium, K, Na, K, Rb respectively? All of these elements are in the same group. And again, just like question number 1, as you go down a group, the size gets bigger. So you can think of very much like a snowman. So as you go down a group, atomic radius increases. And B looks most like a snowman. Just to finish off the atomic radius trend, you have that nose. So as you go across a period, the atomic radius will decrease. Number 5, at STP, which element is brittle and not a conductor of electricity? So for every unit except for gases, which is unit 6, we can ignore STP. It stands for standard temperature and pressure, but does not at all affect the question. So brittle and non-conductor, this sounds exactly like a nonmetal. So go ahead and identify each element. Sodium is a metal, argon is a nonmetal, sulfur is a nonmetal, and K, potassium, is a metal. But we have 2 options. The key word here is brittle. That means it's breakable. Argon is group 18. It's a noble gas. You can't break a gas. But sulfur at STP is a solid, and a solid can be broken. So as long as you know that Ar is a noble gas, then you can, by process of elimination, figure out that it is S, sulfur. Number 6, which list of elements contain a metal, metalloid, and nonmetal? So again, you're going to list out everything. Once you list them all out, C is your answer because you have metal, 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 non-metal, 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 and metal, metal, metal there. Group number 7, elements in group 2. So again, we're talking about that second column in your periodic table. These are all metals because here's your staircase. Everything to the left is a metal. Everything to the right of that staircase is a nonmetal. And if you are the staircase, you are a metalloid. Number 8, which list of elements is arranged in increasing electronegativity? So what you need to know is that fluorine is the most electronegative. So let's draw that over here again. Fluorine is your most electronegative. So as you go across a period and you're getting closer and closer to fluorine, the electronegativity is going to increase. There is also ionization energy that follows the same trend. So electronegativity is the want or the affinity for electrons. So the closer you are to getting that full shell, the more you want it, the more electronegative you are. Ionization energy is the energy to remove an electron. So the closer you are, the more you want an electron, the more difficult it is to take that electron. So therefore, electronegativity and ionization energy do the same thing. As though you're going away or down a group from fluorine, your electronegativity and your ionization energy will both decrease. Again, these trends or these patterns, knowing the pattern can make it a little bit easier, but all these values are on table S. So if you're ever not sure, double check table S, it is there. So if we're looking at all of these groupings of elements, we want an increasing electronegativity. So we want something that is moving across a period. So if we look at Li, Na, and K, these are moving down a group, therefore electronegativity decreases. FCl and Br, we're also going down a group, group 17. The elements are decreasing electronegativity. If you look at K, Ca, Sc, we're moving across a period, which is exactly what we want. That is how electronegativity increases. And just to round out our answers, this is also going down a group. Therefore, find the one that is different. Number 9, which list includes elements with most similar chemical properties? So you want elements in the same group. Elements in the same group have the same number of valence electrons, and that's what allows it to have similar chemical properties. They're going to do similar things to get that full 8. So if we look at all of these element pairs, only O, S, and Se are in the same group. Number 10, pure silicon is chemically classified as a metalloid because this is a strict definition question. It exhibits metallic and non-metallic properties. It's that halfway in between, medium point between the two things. Generally, they look like metals and act like non-metals. Number 11, at STP, which element is a good conductor of electricity? This is a property of a metal. So you have to go and figure out which one of these is a metal. All of these are non-metals. This is your only metal. Again, sometimes they'll give you the element name, but silver is Ag, iodine is I, sulfur is S, chlorine is Cl. So if you forget which is which, you can easily check table S for that. Number 12, the element in group 14, period 3. So you want to find group 14, which is over there, period 3, which is somewhere around there. That element right there is Si. Si is on that staircase, making it a metalloid. If we continue, number 13, which properties are characteristic of group 2 elements? So group 2, again, we are talking about metals, and we're talking about electrical conductivity and electronegativities. So we had said that as you go across, electronegativity increases. So if the highest electronegativity value is on the right-hand side, things on the left are going to have low electronegativity values. We also said in previous questions, and this is just a good fact to know, metals are good conductors. So we want to find an answer that has low electronegativity and a good conductor, and that is answer choice A. The fact that it says 1.7, don't fixate on that number, but you also can check table S and solidify your response that way. Number 14, you have a lovely table full of information. Based on this table, which statement describes how two of these elements can be differentiated from each other? So you want to figure out what is different. Gold can be differentiated from sodium based on malleability. Sodium and gold, they're both malleable, so therefore that doesn't work. Sodium can be differentiated by tungsten, which is W, based on conductivity. Sodium and tungsten, they're both conductors. That can't be it. Gold can be differentiated by tungsten based on density. Gold and tungsten, they have the same density. That can't work. But if you look at sodium and iodine based on malleability, sodium is malleable, iodine is not. That's what makes it different. So it's all about reading that table. You don't necessarily need to have knowledge of chemistry. Number 15, at STP, which element is malleable and a good conductor of electricity? Again, these are all properties of a metal. So if you list out all of your things, hydrogen is a nonmetal, silicon is a metalloid, xenon is a nonmetal, and platinum is a metal, making it answer choice C. Number 16, elements on the periodic table are arranged in order of atomic number. Again, this is something you just need to know. This is a very important question. At this point, we haven't really talked about oxidation states, but the reason we can't use mass or mass number is, remember, isotopes exist. There are the same element, but with different masses. So once you introduce all of those isotopes, that throws off the order. But remember, atomic number is the same as the number of protons for each element, and that is what is unique to each specific thing. So we are organizing our periodic table based on atomic number. Okay, moving forward, which group 14 element is classified as a metalloid? That is going to be Si. So if you're ever not sure of the names, because again, you have the symbols on the periodic table, silicon is Si, carbon is C, tin is Sn, lead is Pb. Table S has that for you in case you ever forget. Number 18, based on table S, so it's telling you where to go, which group on the periodic table has the highest electronegativity? So remember, fluorine is the most electronegative. If you forget that, you have table S to look at. All the things in group 18, those are all, again, those noble gases. They don't want more electrons because they already have their full valence shell. So the electronegativity values for those elements aren't even there. So group 17, specifically fluorine, is the most electronegative. Okay, number 19, which statement describes the general trends in electronegativity and ionization energy as the elements in the period 3 are considered from Na to Cl? So we are moving across a period, and period are the rows, groups are the columns. So you have Na, you have Cl over here. So we're moving closer and closer to fluorine, so therefore electronegativity is going to increase. And ionization does the same thing. Because again, the more you want an electron, the more electronegative you are, the harder it is to remove that electron. So therefore it takes more energy. So we want something that says electronegativity and ionization energy both increase, making it C. So again, they're both doing the same thing, so you can get rid of at least 2 answer choices there. Again, if you forget, look at the values on table S for all those elements and you can figure that out. Number 20, what general trends in atomic radius are observed as the atomic radius and electronegativity are observed, and the elements in period 3 are considered in order of increasing number. So we're going left to right. We just said electronegativity increases, but if you think back to our atomic radius snowman, as we go across, your atomic radius actually decreases. So answer choice C, atomic radius decreases, electronegativity increases is our answer. The whole reason as to why atomic radius gets smaller as you move across the period, not the most relevant of things, but if you wanted to check out the trend video, pretty sure it is mentioned there. So moving on to our short response questions. 21, the elements group 2 on the periodic table can be compared in terms of first ionization energy, electronegativity, and general properties. Explain in terms of electron configuration why elements in group 2 have similar chemical properties. They all have the same number of valence electrons. That is what makes it have similar chemical properties. So we're talking about electron configuration because we're talking about the valence electrons. They are the outermost electrons. You could also say they all have 2 valence electrons because that infers that you're looking at the electron configuration on the periodic table. Number 22, identify the element in this table that is classified as a metalloid. It's literally just Si. You do not need to write full sentences, just identify the element. That is it. Number 23, you get a lovely graph, and it says state the trend for the atomic radius of the first 7 elements in period 3. So again, we're going left to right. Based on just our snowman, we know that atomic radius is going to decrease. But you also have this graph, the number is getting smaller and smaller and smaller. So if you remember the snowman, if you look at the graph, or just looking at table S, you have multiple ways to getting the same answer. Number 24, identify the element in period 3 that is an unreactive gas. Unreactive gas, we are talking about our noble gases. So that is group 18. So the element that is in period 3, group 18 is going to be argon, Ar. Again, that's all you need to write, just the symbol or even just the word. 25 gives you a lovely paragraph. We're not even going to bother reading it. And just identify one element that'd be chemically similar to UUT. So again, if you are chemically similar, you have the same number of valence electrons. You're going to be in the same group. So if you find UUT on the periodic table, you'll find that right above it is TL. Above that is IN, GA, AL, and B. So any one of those options counts. You just have to pick one, but whichever one you want, that is fine. On that note, that is the end of this video. We've gone through all 25 questions. Hopefully you found that semi-helpful. Good luck on your test. Bye.